Hello, welcome. We are continuing to work with classes today. Uh, I did give you the watch example, and they have from the book a dice example, but this is the outline of the module, and some of the main things that I want to focus on would be we've already talked about classes and data information hiding with that watch example that I gave you, encapsulation. We don't want people to mess with our data and the objects. But here's the one: method declaration. And parameter passing. So we're going to have functions, behaviors in our objects that we use. And we are already using one function or behavior that's automated, and that's the constructors. So I'm going to delve into that a little bit, but here's the big one: events and event handlers. That one, of course, with buttons and text fields, and we'll try to introduce some of these other ones that we may, probably images. We may do a demo that includes drawing an image with some kind of event handling going on. In fact, actually, hopefully I'll remember when I get to the demo. No, I will. Let's actually take a note on that. That sounds like a good idea for this module. Let's see, Notepad. Oh, we got all kinds of new stuff. Okay, cool. All right, there we go. So yeah, let's do this in demo, just so I don't forget. Create an image, move it with a button and an event handler. Now I've got a dice example, some code that does some of this, but we're going to go ahead and just add that in as part of what we're going to do during demo, just for fun. Okay, and then we have more on objects as we're kind of going through here. That's the way the book is, because everything's object oriented in Java, so they introduce new things while you're learning about objects, which usually in traditional computer science we don't learn about objects until after we've learned about everything else. But yeah, so let's get into some of the nitty gritty and some of the examples of classes. Here's a good example of state and behavior. And we talked about state and behavior a little, well, actually, when we were talking about the watch, the state is being the time of the watch, hours, minutes, seconds. And the behavior is the ability for the watch to change its own time. So we've really already covered this. So I'm going to go ahead and skip through. And we've talked about objects, but let's get a good rounded view on the anatomy of objects. And that is just the data and the methods. And so we're going to work on some methods, creating methods in your assignments. And we got the example of the rolling dice. Here is several die. Now notice that we have an object that is going to represent the dice. And inside that object is the data for the dice. But this doesn't show the object. This is just main. And then rolling the dice. But we see we have the instantiation, and then the constructor runs, and we roll the dice, and each roll is the behavior that changes the data inside the dice. So here it looks like we have the die object, the dice object. Notice that we have a maximum value of the dice that we can set up, and then what is its face value? Then what we're going to want is maybe either a constructor that rolls the dice for us, or any kind of behaviors that a dice exhibits that we want to model on the computer. And we can take that modeling and also convert it into drawing the dice on the screen and visually rolling it. So yeah, we're gonna build this, and we're gonna implement the two-string method because I'm already sick of PowerPoint, and we just started. But what I like about this is we got this embedded in, and we can have a little fun with it as we progress through it. So let's do it inside of a Maven project, though. And this is the Maven project that just draws a rectangle. Maven, excuse me. JavaFX project. So, and we're just going to throw it in the background of that. Let me close this guy out so that we just have one project open, period. And all this other stuff, this junk, that's all just stupid stuff to get all the code that JavaFX needs included in your application. All right, we don't need some of this stuff though. We don't need any of this. And what we can do is, actually, you know what? Let's just keep the rectangle for now. We don't need that other stuff though. I don't think we do. Oh, whatever, fine. Mess with me. I'm got other things to do. All right, we're going to go with a Java class, and we're going to call that die. I showed you could do this a different way if you wanted to. I want to add it to the source package that I'm currently working with, which it looks like it's Maven Project 1 from my namespace. And then I'm going to hit finish here. Okay, we have our die class. Let's go grab the code for it. And then, you know what? I'm going to go off screen, get all the code for this. And then we're going to come back and we're going to implement that we're going to test it, and we're going to implement that two-string method from the PowerPoint. All right, let's play with this a little bit. We have our dice. Let's run through the motions on testing. I want to set a breakpoint, do a step into some of these functions, and then we're going to side call a function from another function and pass a parameter. So we have two different types of functions, main functions. We call them, they each have read or write access. We also call them accessors, getters and setters. And it's a main tenet that whenever you have data in an object that needs to be changed outside of the object, meaning it needs to be set by either the user input from some kind of user input or some data that comes in from a data stream of some type. We want to control how that data is modified within the object for abstraction and encapsulation. And that means then that we want to set up a filter for face value, most likely, if we wanted to. So that would allow us to control read and write privileges with what we call get and sets. So if I did not want to allow any write privileges to a user of my object, I would not, and let's say that the user, the data that I want to protect is face value, the roll of the dice, essentially. What did it roll? 1, 2, or 3? And let's pretend that if the face value rolled anything other than 1 to 6, the apocalypse happened. the end of the world happened. We don't want people to set our dice for any values other than 1 to 6. And that's where we would get into control of that data with mutators, accessors, getters, and setters So if I didn't want anybody to change face value, then I would just literally get rid of set face value. And now, and because face value is private, anybody who uses my object has no ability to mutate face value. And that's what we call a mutator. And so right here, this function, set face value, let's Control Z that, set face value, that is the mutator. That's what changes it. This right here, get face value, that just returns as read access. So you have read access to data inside the object with your get accessors, and you have write access to the data in your objects with your set accessor functions. And these are all public and meant to be used outside of the scope of the class, meaning from main. So you're not using it inside of the object's functions or at all in any of the functions. It's all coming from outside the scope of the object main, which then has access to the public methods that are available to it, but it does not have access to the private. And let's delve into that. So let's go into main, and what we're going to do is we're going to create a die, and we're going to say var die equals, oh no, var, this is where we're going to give it a name, dice1 equals new die, and this is where we invoke the constructor. We can overload that if we want to, but I don't believe, I think I might have a few fixes that I got to do here. I might need to include it, but let's see, where are we at? Did we get it? No, no. Okay, so it apparently likes that code. Let's look at it. Let's look at what happens in debug mode when we instantiate that dice. Are we even? Yeah. Okay. So it doesn't look like the breakpoint is even happening. So I think I might need to. Let's start up here for a breakpoint. Okay. Well, apparently my debugger is okay. Well, this is a good opportunity to show you how to move code between different projects. It looks like my Maven project, I'm having problems with the debugger, and I really don't want to spend the time to get debugging in JavaFX working appropriately just now for this. So what I'm doing is I just created another regular Java application, and I'm going to take this die object and I'm going to copy it, and then I'm going to go up here to this package for this other project, and I'm going to paste it in. There, now it's in there. That's interesting. It's a copy, but it's asked to refactor first. And what it wants to refactor is, if you look at the die, we put it in project, the Maven package namespace. So what we want is we want the namespace of the new project, which is, I called it Java Application 6. Well, I didn't call it, it was auto-generated. So let's put that in there, and then now we can start to do our little bit of debugging. Let me get this in here so we can really look at what's going on. There we go. Okay, so let's get back to where we were. Here's our main. And then I'm going to say that var dice 1 equals die, open close parentheses, equals new die, new die for the constructor. Okay, now let's set the breakpoint here so we can step into it. All right, let's say stop, debug. Okay, I'm not doing the Maven anymore, so I'm just going to close that. Okay, now I'm just doing the regular one. Okay. Oh, wonderful. This is great. Right when I'm doing the video. Oh no, it's working. That's good. Okay, good. I was about ready to freak out because it's stupid debugger. I was like, what broke it? Well, JavaFX broke it for now, but I'll fix it. Okay, let's step into this construction of the new die. And what it's going to do is when the new die is instantiated, that's what we're doing is we're instantiating the die. Now we could do this two different ways. We could declare the pointer to the new die and then say dice1 equals new die. And that's, we only do that, you know, when we want that reference. And I don't even think Java might not even handle it that way, that well. So it's all done in one. The pointer, the reference, and then we ask the operating system for memory off the heap using the new operator. And then that's going to return to our dice and create our dice for us. So let's step into and see what that's doing. Okay, so essentially the constructor runs, it constructs all the data in the object, sets face value equal to 1, and we're done. Fairly simple. One nice thing about object-oriented programming that we usually do with every language, it doesn't matter, C# does it, all other languages do it. What we invoke, or what, excuse me, not invoke, well, what we create or define is what we call the toString function. The toString function is just something you create, and the intention of the toString function is that you will output the data that needs to be shown from the object in its ASCII form. And so you're going to have numbers that need to be converted into strings to be able to be printed easily on the screen. So remember, data input, string to numbers. Data output, numbers to strings. It's always that way. So you always have that string in between whenever you're doing input and output from a process. Okay, so that's why we create this toString overload. And what it does is when we tell it to print an object, and let's say right here, as an example, if I wanted to print the face value of dice1, I would run the system.print line print, I think it's just print, dice1 dot get face value. And that would print the side of the dice. Let's see, did I do something wrong? Oh yeah, I forgot that. Okay. And I think my print, oh, I forgot the out. Okay. Oh yeah, okay, so that should show up on the IntelliSense. Let's see what we got. I think I print object, yeah, print string, print, right now what we're doing is it's gonna run that one, print float. If that's what we're sending it. No, what we're sending is an int, so it's gonna run that print int. But what if we decided to tell it to print the whole object, the whole dice object? Because right now we're telling it to get the face value and print that. So that means that this function runs first. And we can step into and see what that is. But that is one method of printing the face value. Now let's just run it. It's going to print 1. There's our 1. So that's good. But what if I said this? Print dice1. Well, what's dice1? Dice1's an object. But the print function, it has the ability to take an object as an argument. But it's not going to know how to print the object. Because the object can have any kind of data type in it. Any kind of data organized in any kind of way. So we need to tell it, the print function, what to print. And that's when at the lower level, at the object level in the inheritance hierarchy, that print function is called, and we can override it and catch it and use the R's instead. And that's what the override does for our toString method, is that whenever the print needs to know how to print an object, it's going to run the toString implicitly. That means we don't do it, print does it. We just got to set up for it. It's kind of like the constructor. So the constructor is automatically called implicitly. And in this case, whenever we use a print on an object, or whenever we need to use or have some method where we want to see or view or convert that object to its string, and the string representation of that object is entirely up to you because you're the author of the object. Well, in this case, we're going to overload this toString function so that it allows us to do that. And then we're going to get back into accessors and mutators and create a filter. We haven't finished our filter yet. We've talked about accessors, mutators, but did not finish our filter. So let's go finish our filter and test out this toString. So I'm going to throw this toString in here. Okay, now that's going to be what runs when we try to print it. So we'll play with this, and I'm going to set a breakpoint in here just so we can catch it for fun when we call the print function on the dice. So I think we're ready for it, because in our main, aren't we just saying print dice1? Yeah. So if I set a breakpoint, do a step into on that one, it should call the toString method, unless I'm lying to you, and that's happened before. And you see here that our breakpoint happened for the toString method. Okay, now we can do it the other way, top down, where we call it in from main, set the breakpoint, and we can step in behind. But the problem is, we got to set the breakpoint above, because this line isn't actually processing. We can only breakpoint on a processing line. So right here, I'm going to do a step over, and then now I'm going to do the step into, and that's where we see from top down that the toString method is called. Okay, I'm going to do step into again, because this is code this is the toolchain code that's working for us at the bottom level. This is the print function calling at the very bottom of the hierarchy of objects. So actually, you know what? I'm sorry, guys. This is where we have to get into a little bit on some scritch. We got to get a little squiggly. It's squiggly time. We got to get into, how does this toString work? How does overrides work? What's happening? What's happening? All right, let's do it. Oh, whiteboard. All right. All right, you know what? We're going to try something different. Let's use Word. Word does just kind of a whiteboard type of thing. All right, so in the hierarchy, at the very bottom of Java, you have an object. And then it can go up to like a control or a string, an int, all up the hierarchy. And there's multiple different hierarchies that object has. So essentially, object is a base class of our object. So we have an object that we created that is inherited implicitly from the object class, very base class, at the bottom of the JavaScript hierarchy. It's all based on that object. One data type, guys, for the whole language. Everything's an object. So our dice is on top of this object, and inside of this object is the print function. And that print function, when we call print dice, it goes down the hierarchy, down to the object part of the dice, calls the print, and it knows to call the toString method of itself. And since it's a dice, it calls the toString method of the dice down at this level with dynamic binding. And that's just a little bit heavier than we need to be, but that's an example of where I'm at now on the call stack. I'm now at the object level calling the print, the toString method. So if I do step into, it should go to eventually get to the toString method inside of our object. it looks like, oh, let's do it this way. Step into. Yeah, there it is, right there. There's our toString function. So what it did is it went down, the runtime went down to the object level of the dice. And it looked, and the print function, the object knows how to print itself, but it also knows that there may be a toString method of an object that inherited from that base class. And that's what it calls that. So there's a lot of stuff that you're going to be learning about as we progress that goes into how the mechanics of this language work, because you're coming at it and you're just looking at magic happening. I'm trying to, we're going to reveal that to you a little at a time. So we're going to invoke that toString just so that we can have print behaving appropriately the way that we want. And what we can do is we can add some stuff right here. The result, we can add in the dice rolled and then we can throw in a plus here and add the face value. Now that's going to be called every time the print happens of the object. And so that's why it's nice to add a toString overload to your objects, because it makes it nice and easy to drive them. And what I mean by drive them is in main, instantiate them, and then test them. And then verify that your test worked. Set a breakpoint right here. Okay, good. We instantiate a new die. The constructor is invoked. We roll the dice. After the dice roll, we can look inside of the dice and see what it is. Let's go over here to our variables. We should see dice. There's dice. Break it down. We see that the face value is a 1. Okay, so it's going to print the 1. Excuse me. Oh, rolled a 3 because we didn't do that yet when I was debugging. Oh my goodness. Let's start over. Starting over. Okay. Come on. Start over, you silly thing. All right, there we go. Step over. Now we're going to roll. We're going to step into. We roll. Face value is now, we look down here, face value, variables, face value. Did they show it? This face value right there, 6. It rolled a 6. Okay, so then we print it. Done. Okay, so that's a lot of time on just the toString, but it gives you a little bit of an understanding of how that works. And then now let's look at filtering and calling a function from another function. So we got filtering here, where I want to allow mutation of the face value, but I want to control, mutation is the set. I want to control that mutation and add a guard. And so what I'm going to do is I'm going to say, hey, if the value of the new value of what we want, of what is coming into the set function, if that is not 1 to 6, that means it's less than 1, or the value is greater than 6. We're going to do a silent deny. We're just going to say, out of here. No. You don't get to do nothing. Nothing. We filtered it. I love the silent denies. But yeah, you actually really should, in some ways, sometimes have a return value so that you can say, hey, this worked or not. That's a possibility when you're working with filters and functions. So face value changes it. Now right here we don't have to return anything unless we want to have an answer back to whether it was succeeded or not. Right now we're just returning and saying out. We're done. You're not allowed to change it because you didn't send in a good value. Silent deny. Those are kind of nice because in some ways they're implicit and they don't cause too many issues other than finding out that it's an issue. Well, what do they build debuggers for? Okay, let's get back into some filtering and calling functions from another function. So we filtered it, but here, let's look up here at the constructor. You see where we're setting face value equal to 1? That's a big no-no. We should not be doing filtering or setting here. We built something to set the face value safely with a guard. So that's where we need to actually, instead of just setting face value right here, let's run the set face value function like we should. And this is just an initialization, so that's fine. Eventually we would have another object. In fact, another constructor. Let's do this as another constructor. This is called an overloaded constructor, where we pass in the value of the die that we want. Now you notice it's just the same except for the argument list, and then we're going to say set the value. So then when we instantiate it, when we instantiate the new dice for the constructor, we can pass in the face value we want it to have. Or, hell, why are we even doing this? Let's just roll it. Oh, that won't work. Because we have to have it exist first. I was getting silly. All right. So let's look at that. And it won't do the other one. It'll do the new one. So when I step into, you see now value comes in there, and I'm calling another function. I'm saying, hey, set face value, and I'm sending in the value. So I'm going to step into that. I'm going to do a step over. Oh, crud. Oh, you silly goose. It didn't do what I want. Oh, there we go. Okay. I'm going to do a step into here. There. Set face value. My filter runs. Value set. We're good. Okay. All right. That's a little bit on the die. Let's get back into some PowerPoint, see if we're missing anything. It's calling function from another function. The die class we talked about. Constructors, data scope. That's a good one. Let's do a little talk on data scope. Okay, data scope is when or where an actual variable is accessible. So where is it declared? What scope is it declared? And where do you have accessibility? So we'll come back to that. Let's see. Let's do it within the context of program of this example program. All right. If I create a variable at function scope, and that means that it is in main or another function. In this case, the function, when it's called, goes on to the call stack. And then the variables that are declared and used inside of the function also go on the stack. And they are only available within that region on the call stack, within the function's call itself. So it's all contained together. And that means that if you create a variable here, if you define a variable here and use it, it's not created and put on the stack until this function runs, and it's only available within this function. Because it doesn't go on the stack unless it's part of, so it's only available within the scope of the function. I can't just go out here and say, I want to take dice 1 and assign it to something. Now this is what we call namespace scope. This is at the scope of the namespace. Oh no, this is object scope. This is at the scope of the object. So that means starting here and ending here, anything, any variable, anything that I declare is accessible between the start of the object definition and the end of the object definition. Main just happens to be a function inside of it. And it's kind of, it's static, so there's only one main. But when we take into consideration other objects, the scope of this object, there's two scopes here. there is file scope. That means you declare variables out here, which you can't do in Java. Because everything has to be in an object in Java. There's nothing else exists except for that low-level object. Everything is inherited, and even your dice, a string, an integer, all are that object. And everything has to be an object, and all code has to be inside of an object. So mostly you do not work with file scope. You define objects at file scope, and we call these global variables. So I could create a variable up here in another language and be able to access it anywhere below. And that goes with also the top-down behavior. Because if I declare a variable, I cannot use result here. Because what's result? We don't know what result is yet because we haven't declared it yet. So you got your top-down behavior when it comes to scope. You have to have, when you declare a variable within a scope, you have that top-down behavior that it has to be defined before you use it. And then you have the braces that declare or define or tell you where your scope is located at or what scope you're working in. And so variables that have to go between scopes, they can work just fine because these variables are at the die scope. That means they exist for the whole object. When the whole object goes on the stack, all these variables go on the stack and all the behaviors that go with them that go on the stack that can be used. And these variables are at object scope. And then we can go back to the other scope that we have, which is our starting point scope, which is this function called main. And we declare a dice1, and we have dice1 available within that scope. Let's go back to the object example. Let's say that I create a variable down here, right here, var, or let's just say int I equals 3, something like that, something simple. I can't just go over here and say I equals 2 because I only exists in this scope when it goes on the stack. It does not exist over here because roll is not on the stack yet until it's called. And therefore, no variables in it are even available to be used. When you create the whole object, all of it goes into the same scope. And so these functions have access to this data that's inside that we're protecting because they're all in the same scope. Start of the object, end of the object. Everything can talk to each other within those braces. If it's function scope, boom, then it's only available within that scope, within this guy right here. When you instantiate dice1, that's where it creates that whole object and everything inside of it together. And all of that, if it's in that scope, they can all talk to each other and work with each other. All those functions and variables. So if we try to call something that's private outside of scope from main, we do not have, you see here, there is no just face value. We can't just say face value because it's private. Now, if we want to allow somebody from outside the scope of our object to have access to something inside of the object, we have to declare it as public. And then we can do that. But that's a big no-no because that's breaking all the rules of abstraction and encapsulation, data privacy. I mean, when you think about computer science, what's the main thing? Data. Data. Yeah, that's real simple. All right. Did we hit? Oh, we haven't got to some of the other stuff yet. So we will, we're good here. Instance data, UML class diagrams, a lot of that encapsulation. We've been talking about this whole time. Visibility modifiers, access mutators, we talked about that. That's the big one. Method declarations. You guys get into that. We did methods. We called a function from another one. I showed you a little bit on control flow. We know how body works. Return statement. That one we didn't really get into too much. Let's talk about that one. So the return statement we've been using implicitly. Let's be a little bit more explicit about it. Let's go into our die program and let's look at the different things that we have. We have a return face value for the role. Let's look at that. Notice here that in the body we say int and we're returning an integer. So we needed to tell the function in the definition of the function what it's returning. And then we have to return it because if we don't, we get an error. Now look at this one though. Set face value. It has void as a return value. Void means nothing. So how do you represent nothing in computer science? Well, we have to have something to represent nothing. That's what void means. It's just nothing. We're returning nothing. But you see here, I call return. I'm using return just to bounce me out of the function so that I don't run this line. And it's okay because I'm returning nothing. Look into the continue function. The continue the continue operator. Because that has similar behaviors within a loop though, but it doesn't back you out. It just allows you to continue the loop, but stop the loop at a certain point and then continue it, and then stop, continue. So that is another one that's used for direct control block modification or behavior program flow control, essentially. And that's what return does, is it modifies your program's flow. So you've got two parts. You got data and flow. What are you processing? What are you doing? So let's look at how this behaves and the role behaves. Okay. Okay, step into. Okay, we roll it. We set the face value, and face value is an integer. We go up here. Yep, it's an integer. So we return the face value that has been modified. Now this would be something that I would actually want to do the filter on. But since it's an internal function and I know how it works, I probably don't need to. It's probably inefficient. So we return the face value, and what we want to actually do, oh, excuse me. Yeah. We don't return the face value. I'm sorry, I went down a rabbit hole the wrong direction. We return the face value, yes, but we're not capturing the value. We are setting the value of the face value here, so we're doing that. And we're returning what was rolled. So right here, I'm using it in just the one way where it modifies the roll. But if I wanted to know what was rolled, I can assign a value to it. And I could say data equals dice1 roll, and it's got to be an int. Int data, and data equals, or I can just say R. Let's just do R. That's the roll. So it both modifies the data, what's inside, and then it captures what's returned. Okay, let's look at that one again. Now that we got it working, right? Okay, there we go. Step into, boom, face value. We set the internal first value. So we actually really don't need to return the value, int roll, but it might be nice and it doesn't cost much. And so we have the new value R assigned to what was rolled, 6. And that's returning values from functions. Now we do another one where I say, you know, get out of Dodge because you're messing with me. And that's when this is set wrong. When we try to set the face value incorrectly. So I'm going to step into this and notice the value is going to trigger this because the value is 8. And so it's going to return. And it's going to return nothing. It just returns back to its calling point for the silent deny. And it didn't do anything. It didn't set the base value. It was just the silent deny. It didn't allow that code to be run. So this is an excellent example of most of what the chapter and kind of what we went through is getting at. Let's see what else we need to hit, because I know we want to do event handling and some JavaFX stuff. Hopefully I can get my silly freaking yeah, here we go. Let's just do images. This one would be fun. Okay, yeah. This is next. We're gonna play with this. We're gonna actually, we're gonna get it going. We're gonna do something with that. There's a lot of ways you can play with images. I mean, I've got some other stuff in here. I've got some more videos of rolling dice that I've got around. They're older. I think I made them available somewhere, but I'll look again for that. All right, let's play with some JavaFX, and for that, I'm gonna have to open up the project. Now, actually, no, I'm gonna create a whole new project because that one wasn't debugging very nicely. It was being a stinker. So let me get going, and you know, hey, if it doesn't debug again, maybe I'm gonna have to attach a debugger that will handle Maven or JavaFX. All right, see you guys soon. I'm gonna go get that set up. Okay, good. I got a new project. Something was probably wrong with that one. I just went to File, New Project, and I went to Java with Maven, and I chose Simple Java Maven Archetype, and I hit Next. And now I've been given this. It added our dependencies. It appears to be working. The debugger is running. Let me do a continue, see if it pops up. It should. Let's see. Let's do this. Good. All right. So here's our goal. Let's draw an image, set up an event handler that every time we click it, it's going to randomly put the image somewhere else. So this is our demo. This is our demo for this week. And it's going to demo images, event handling, and location changing, I guess, in the canvas for drawing it. But the draw image for canvas systems, you can do two different ways of working with images. There's an internal image class or image list that you use for images. There's an internal image control that you add. And then there is the way of doing images where you just draw it to the canvas using a function. All right, so let's look at our example of an image. It looks like we are using an image view, so we're definitely going with control-based imaging. It's not based on canvas. So this is usually the introduction of working with images because it's easier to get going. The canvas draw image is probably a little bit better at being able to do animations and stuff. So let's work with some image controls. And I think, you guys can look into drawing images with canvas or on canvas. I've got videos of that coming around, but we won't be doing that for this example. So let's grab that code and make it work. Okay, first I grabbed the includes that are needed. Let's just do a rebuild on that and see if we're compiling right. Looks like we got some errors. 3 source files. Let's see, where is the build failure? Cannot find symbol. It looks like we're getting some includes to work out. Unused imports, that's not bad. Yeah, because I think I overwrote stuff that I shouldn't have. So I just did Control Z. Let's paste in the code that's needed and get rid of the duplicates. I think I lost for my label. I think I lost an include for the label, and that's why we had the error. But that's okay. This is a better way of doing things. Image view, good. Stack pane, we already got, good. And then we already got stage. So these are the three that we need. Yeah, let's clean and rebuild. See if we got all the libraries that we needed. And it looks like we are good. We succeeded. So now let's get into the code. And I think we can directly grab that little piece at a time. Here's this. Let's grab this guy, this code, and throw it in here. Let's just do it down below for now. Oh, I got the wrong copy. Come on, give me some love. Give me some love. Okay, there we go. Maybe that's why. Okay, there we go. We got image view. Let's just see if we've got these guys. There might be some weird there might be something from the copy paste that I gotta get rid of. That's really bad. So get rid of some of that white space, guys, in case it's got some Unicode characters from copying it from the thing. Okay, I think it's good. Yeah, that's whenever you copy paste code, guys. You're gonna copy in characters your editor won't show, but they're there, and the compiler, I call them ghosts. The compiler will still see those characters and it'll puke, but you can't see them in the editor because they're in Unicode and some weird thing, and you copy and pasted it in, and the character's there, but you don't see it. You don't know. Well, you see a little bit. You got that weird stuff, but. Okay, so just get rid of the white space when you copy paste, or copy paste into a notepad and then go into your code. Just be kind of cognizant of that. It causes a lot of problems with students often. So let's get the last bit. Okay, I'm gonna copy that and we get back into our code. Good. Okay. Clear out the white space with all the crappy characters. More white space with crappy characters. Get those gone. Okay. Trying to show you the process here, guys. I know it takes a little bit of time, but you know, some of the silly stuff really rubs off. Okay, so we probably got a problem here somewhere, definitely. Let's just get rid of all this stuff. Because the stage here is where we need to port to, because the stage is given to us from our start, so we have to use this stage. It's given to us from the language, or from the Okay. Is that gonna get us our image? No. Because I don't think I've even set up the image yet. So it's probably gonna puke because it doesn't have an image to show. It just has a stack pane to show. So something's gonna go break.
Trying to stay up as much as I can. But it's been kicking me a little bit.
Sorry for that little interruption there. This is going to be a little bit longer video because we're going to do our demo together with it. And that's what we're doing right now, actually. This image is, the problem that we're having with this code is, let me get to it. Let's see. Which is what I expected. I kind of alluded to that a little bit. But it wasn't even compiling. It said a build failure because it actually, Java can test code to see if it works, or kind of get an idea of what's going on. it does several passes. So right here, this guy right here, Java was able to look at that and say, hey, there is no goal.jpg in my working directory. So the working directory is the directory where your process is actually running from. And that is going to be part of your inside of your project. If you're running the program from the project, it's going to have a working directory that's in the project itself. So we want to put a goal image or some kind of image in our directory, and we want to have a good path to it. And the best path is implicit, just like this. We don't want, because if this application, if we're going to give it to somebody else, we would give it with the resources to it. And that you can also add images as a resource. I don't like doing things that way. I like to load them up dynamically instead of put them, because if you add the image as a resource, it actually increases the size of your program, because the program has to be packaged with that image as a resource. So the size of the program increases. But then again, if you need to send out that image for deployment for the application with the with the program, then it's still bigger. So it's just more hassle when you get to deployment. And that's why the resources and embedding images into your executable, it's easier for deployment, definitely, when you deploy your application, because you don't have to deploy it with images. In this case, doing it this way, we have to deploy it with that image. That means that anytime we give this app to somebody to run, we should be giving that image to them with it. So we need to find the working directory of our project and put that image in there. We can also be very explicit and use full paths. Now, we have to use the double backslash because this is a formatter. So we use the double. And basically it's just telling it, no, this is really a backslash. So that would be the full path to where we could put it. So let's just try that. Let's just try gold.jpg on the C drive. Let's find a different image. Let's find a fun image. Let's find that's my email. We don't need that. Let's go funny looking seagull. Okay. Yeah, that's good enough. Save image as. It's a JPG. We're going to go ahead and put that on the C drive, and I'm going to call it goal. It's going to be in the C drive. I'm going to call it goal.jpg. Say yes. Okay. What? C drive. Save. Oh, I need an administrator. Okay, fine. You don't like me. We would have to run this as administrator to do it on the C drive. It just does not like me. Let's do it easy on the D drive. I've got write privileges on the D drive. That's fine. That's fine. Yeah. Save. There we go. Okay, so we'll do this in the D drive. And it's called goal. Now, if we look at my folder, you will see, and I've got a bunch of other silly stuff in here. You'll see that in the D drive, we have goal right there. Now let's see if this, I'm going to set a breakpoint right here just to see if it opens it up. Just to see if it gets it. Okay, I just ran it for debug. Okay, here we go. We stopped on this line. Let's see if it reads it. Okay, let's step over. It looks like, no, still could not find it. So yeah, it gets into a nightmare if you want to do a full path, because you got to convert it to a path for the language in Java. There's a couple different ways. And anyways, this is the wrong way to do it. You can do it though. There's examples. Here's some examples that I have that you can use, let's see, right here. Okay. Let's see. Using paths. That JPG. Ignore that .txt. That's supposed to be JPG. This is one way of doing it for full paths. But the proper way to do it, guys, is just implicitly. You want to load it from the directory that the current program is running in. And what we could do is we could actually save a file, do a save file program real quick just to see what directory that the project is running from. Or we could just run it over and over and throw goal.jpg in different directories of our project. And if we look at our project, let's just grab this and copy it. Copy it. And then let's go to our project, my drive. Oh, no. It's on desktop. Maven Project 2, I think, is what it's called. Silly stuff. Okay, right there. All right. So this is the project folder. It's root. And it looks like we have right here that in this folder right here is the code, the main code. So let's just throw it there. And, you know, I might be just getting sick of the guessing game. You know, so let's actually find the working directory. So let's find that working directory and throw the image into the working directory. And I'm going to use chat for this because I don't remember this stuff. Actually, let's just do an output in the project. It looks like we can print the working directory when the stuff runs. So let's just set a breakpoint there. Because we know this dies. And let's see if we can't step over and get an output that'll tell us the directory. Okay, so let's look at our output. Okay, it looks like our working directory, yeah, okay. That's what I thought. It's the project root. Well, let's see if goal will load from the project root. So let's put goal inside the project root. Okay, so I'm going to grab that guy. I'm going to cut it. And then I'm going to go over here to the project root and I'll paste them in. Okay, well, let's cross our fingers. I don't know what's going to happen. Let's find out. I might have to figure some stuff out. Okay, there we go. Step over. Are you going to see it? Maybe not. No. Did not see it. All right, guys, I'm going to delve into it more. Images. All right, well, we're having a problem. And this is a very common problem when we're working with files and we're not using resource. We're just loading right from the directory. Java is really not liking me right now. So how do I solve this problem? Why am I not able to get this image to load? And I've tried different options and it's not drawing properly. So I'm kind of in a conundrum. Do I search up different ways of drawing the image? Because yeah, there's so many ways, or loading the image, excuse me. There's multiple different ways. But also, hey, what is our working directory? And how can we make this a little bit more bulletproof so it works within the language, so it's resilient? So that's when I say, hey, ChatGPT, this isn't drawing. So I went over to ChatGPT and I said, hey, this is not drawing. And I pasted it in my code. And it's going to say, hey, let's make sure what's going on. Why aren't you able to load that? Let's put it in the root directory and write code to detect if the file actually exists. It's beautiful. I love it. So what I've done is I've just said, oh, you know what? Let's try to get the image this way. So let's take this code and let's get it working, and then we'll take it from there. And this is the proper way of using ChatGPT, guys. Use it to solve parts of the problem. And you know, I'm showing the process because a lot of programming is not about knowledge. Programming is about skill, guys. It's about working within a multiple obscure. There's just so much there. It's just a lot. So I'm gonna test this. I'm gonna run this through. I'm gonna throw it in, and I'm gonna see if we're able to draw the image with this code that is doing some detection and some analysis. So first we're gonna output what is the user directory. What is the user directory? Then we attempt to instantiate the file. It looks like we're not loading that directly into image with this this test. So we're just looking to, hey, can we load any file? So we're using Java IO to see if the file exists. And right now in my root project, that's what it prints for my output right here on this line. It just got done running and it printed Maven project 2 as being my working directory. So I need to make sure, because I've been playing around with it, throwing it in different areas to make sure, see if it'll load. I'm gonna do this. I'm gonna put it here for now, just because that's what's being expected. And let's run this again, and let's see if that sees the file now where it's at. And that's half the battle, is just getting the code to recognize where the file is so that you can load it. Okay, so there we go. Where is the file? Does it exist? Print it. Okay, what does exist? Right there. Go to output. Boom. I don't know if it's run that yet. Let's see. It's got to run it and print it, possibly. Did image view take? Let's look at image view. We can look at our variables and just get an idea of what actually happened. Image, looks like image right there. That's where it's located. So we got that. I believe we're actually loading the image now. Okay. Oh, look at that. There's our goal. All right, so let's get rid of the nonsense. We got a lot going on here. Let's see. Let's get rid of this. This gave us what we needed to make sure the file existed. Okay, and then that's good. We don't need this anymore. We're now loading the image in this manner. So let's rerun it after we took that code out and do it again. Now, okay, so we got one error, and that's probably, where is it? Where's your error? Where's your error? Why didn't you like me? F. Oh, it's because I got rid of it. There. Oh, okay. It references the file itself based on that load. So we just get rid of this guy. Okay, once it grabs it using the file, then we can apply it to the image. And again, guys, there's so many different ways to do this. Okay, now we got, I don't think we need that. One thing that we want to do, and we probably should have done this way before, and that is, let's make sure this runs. Okay, what I want is I want an appropriate try block here so that it tells the user the file does not exist. So I'm going to take that code and I'm going to go over to my favorite person, and I'm going to say add a proper try block around this code so it determines if the file exists. When an exception is thrown, it handles it and prints an error. I'm going to paste in that code. Now I'm just going to see what it gives me and then use it. And this is what it came up with. A nice try-catch block. It sets the image to null. And then it tries to find the image in the directory. If it's not found, it's going to catch the error when it's thrown. And if it passes here, then it exists and we can load it. If there's an error when we load it, it also catches, oh no, it throws the error from the image that will be caught. And so now you can catch different things, different exceptions that happen when you try to load a file. And they could be like, hey, you do not have read privileges for the file as a user in a specific directory. And then you would get a security exception. A regular exception like exception E, that should be like, that would be where the file wasn't found. The other one would be, hey, you don't permission for even looking at it. And that's all done within file permissions for a particular user, whether they own a file or not. So now we've got this code that will do it. And we can just grab this little bit that'll do our try catch for us. And what a try does is it just tries out the code. And it will throw an error inside of the code behind the scenes. So this code is happening behind the scenes, and if anything happens, it's going to throw an error. And it's going to change the flow of your program. Your control, the flow of your program now goes with the exception when it's caught after it's been thrown. Whether the exception is thrown in the code that you're trying to get to working, or you use a function to detect an error and throw the exception yourself. That's the main thing for exceptions. And the try-catch blocks should be used religiously for all inputs. For all inputs. Doesn't matter. User or whatever. Try-catch block. When I am programming and showing you things, I'm not necessarily always in try-catch block mode. Just so you know. Okay, we have some working code. Let's go ahead and try this in our Maven project, and then we're just that bit closer to having code that'll actually work. Okay, so this is just file loading stuff. So I'm going to put it right here. Yeah, because once it's loaded, once we detect it, oh, you know what? That try catch block all works in here, and it loads it up. Once we verify that the image is good and we have no errors, I think then we load it. Isn't that what the code has that we were looking at? Yeah, it's just the exception part of it. So let's test that. Okay, let's do a breakpoint here. That would work because we're setting it equal to null. Okay, here we go. Okay, we're running. I think we're running, aren't we? Well, there might be some errors. Okay, well, let me, oh, no. Okay, yeah, I'm gonna look into those. It appears that the main error here is that I don't have the file library loaded or something like that. Is it in there? No, I need that. I think it's just file. Yeah, right there. That guy. Oops, I don't know what happened there. That was weird. Okay. Whatever. Yeah. Oh, right here. File. Okay. Control S. F5. Come on, F5. Stupid thing. Does it compile? Yeah. Okay. We're running now. Yes. All right. Step over. Okay. We get the goal. Okay. The goal comes in. We load the image. Boom, boom, boom. Then we go and draw the image. And we show the stage. And I'm gonna hit just run here because there's our goal. Okay. Running around there. We got him. Woo! That was a bit. All right. Now we're on to event handling and setting up a button. All right. Well, I've been using a lot of terms here that we haven't probably talked about a lot. And let's go from the top. Graphical user interface, GUI. They really became able to be implemented from a toolchain stand of view easily when Java and C# and Visual Basic really came out with standard ways of doing GUIs. And that is with what we call controls. Now the problem with controls is you can have a control for everything that you would necessarily need, like images, buttons, labels, all that stuff. The problem with them is it's very rigid. So you could do everything that you want by yourself by creating it yourself within Canvas. You can, you can just build your own just by drawing out rectangles and stuff. But we don't need that, and we want something standardized, especially for utility-like applications. Dialog boxes, we like our nice little boxes and drop downs and stuff like that. So the drop downs are your controls within whatever SDK, software development kit, you're using. And pretty much all of them call them controls. And of course we get different things. These controls have different behaviors. And they're all based on how you use the mouse a lot and the keyboard on the control. So that's where what we call event-driven programming comes in. So when an event happens, like the user hits the keyboard, that's when we are able to inject a function that runs when that keyboard is pressed, or when the mouse is moved, or a graphical button is pressed. That is where we carry out the job of the event. So whatever button was clicked, whatever control is using input from the keyboard or the mouse, and we do that through those event handlers. And we can attach an event, and all an event is a function. It's a function that runs when the user does something with that control that has an event that's able to be happened. So any control, you can have a mouse over event. Any control, you can have a mouse click event. Any control, you can have this event, that event. Keyboard events. Any control, you can have a keyboard input event when that control is focused. And so we tie controls to event handlers. So an event handler is that function that runs when that particular control event happens. So if you have a control and you want something to happen when the user clicks on the control, you add a button or a click event for that particular control. And it could be a list box control. It could be a text box control that you want something to happen when the user goes in and clicks the mouse on the text box to enter data. You can get that event when the button is clicked on that control to put the cursor in it and do something that you want to do when that event happens. Or what if they change the text and you want to update the database? So you can do a text change event. So there's lots of different events that you can apply to a control that's going to be rendered on the screen with your GUI. So the first one I wanted to do for our demo was the button. and we're going to need to bring in the button control to work with, or the button library to work with, excuse me. So let's go back to here and let's create a button up here. We've already got our image loading. Let's create a button definition. Notice how oh, excuse me, I'm not ready for the button definition. I need the button include, the import for the actual library. Okay, so that, I think if we do a clean rebuild, that should go clean. That should be good, yeah. So we have the button control that we can now add to our scene or stage and have it rendered. We're going to define it in this manner right here. Button push, that's creating the button. And the text of the button you can use as a argument to the constructor when the button is instantiated. So I'm going to go ahead and declare that button and define it and instantiate it up in the top. We always want to put our data stuff up top. This actually would be something we would want to probably do in the try catch block maybe, I don't know, but it's fine for now. Clean up some of these indenting nightmare stuff. Okay, we got our button. What are we going to do with it? Well, we got to add it to be drawn and rendered on the screen. So let's look at that step. And that's going to be from our examples. So right here, you see right there, they're putting the push button in the flow plane. So you know what we can do is we can put our push button in the pane. Yeah, let's do that. All right, now we're going to implement the event. What happens? What function runs when the button is pressed? What are we going to do when that button, what action? And for that, we're going to apply the behavior of the event, and we're going to say, hey, this is the function that I want you to run when the action of the button is basically when the button is clicked. So there's other event setting. You can set different events for your controls based on what kind of input you're looking for. Let's add this up here to our code. We've got let's add it right when we instantiate it. Let's add in the event to process button on press. Now what that's going to do is it means that we need to actually have that function. It's got to exist. So we've got to create it. And let's actually look at our example from the PowerPoint. And there is our function. Well, where does it go? What scope does it go into? Well, it's got to go in the scope of main. It's got to go in the object scope of main. And the object scope of main, it starts, looks like it starts here and it ends here. So we're going to put it right there. No, this uses it, doesn't it? So we got to put it up here, right there. That's where we're going to put it. We want it to exist before we apply it. So this is going to be the definition of the button press function and what happens when the button is pressed. So let's grab that in there. And what we'll do is we'll just do something fun. What we'll do is we'll you know what? We'll ask. Let's just get the button showing first. Let's start there. We're getting there. So let's throw in that function. That's our event handler. Let's get rid of that copy paste white space and re-indent. Okay. Looks like I'm doing it this way. There we go. All right, and obviously we're already having errors, so we need something for action event. And it looks like we need to import, and that's kind of nice with that pop-up. We can import it and see it added it for me. Okay, now count, we don't know what count is. So this is just from the example. So we're gonna do something different. When the press button actually happens, and that will come here a little bit, because the main thing that we need to do is now draw the button. And for controls to be drawn, we have to add them so that it knows to draw those controls in the scene and whatever pane you're using. So the easiest way is to add it to the stack pane here. And we're gonna just put a comma and add the push function, or push button, the push button to the stack pane. Now remember, the push button is our button that we declared up here. Push me. Push me. We've instantiated it. We've assigned its event. Now we are going to tell it to draw. And so we're going to put it on the stack pane to be drawn. But then we need to say, hey, how are you going to draw this? Where should it go? And for that, we're going to set some alignment. And set the stack pane alignment for push to be at a position, and this is just an enumerator to the bottom center. And let's see, let's see if this will actually, I don't think, maybe, let's see. Let's clean it, see if it'll go. Might need a few more cleaning things. Yeah, I figured POS was gonna be an issue, yeah. I'm just missing the position import, I think, for POS. So let's go up here and throw it in. Let's see, I got it here. There we go. It's in your geometry. It's for positioning it on the screen. There's different values that you can set when you set up positioning. So we're setting up the button for the bottom center in the stack pane. Now, let's just actually, we've tested it up to here. Let's set our breakpoint there and just see what happens. We don't have the button doing anything yet, but I just want to get the button on the screen so that I can do something with it. That's first. Okay. Okay, evidently, let's continue. Let's see if there's a button there. No, it's doing some, okay. Oh, there it is. The button. There, see? Push me. Push me. Oh, I want to push you. I just do you. I pushed you. What happened? Nothing. Damn it. Okay. That's because our event handler, I don't know what's going on with this thing. I think something's going on. I don't know. Whatever. We're not doing anything when we push the button. Look at our function. We haven't said to do anything when the button is pressed. I think, let's do a little fun thing. I think I have the code that will rotate the image. Let me go find it. All right, rather than Googling it and finding 20 different ways of rotating the image, it might be better just to put your code in there and say, hey, when I say in there, I'm talking about an AI, and say, hey, give me the code to rotate the image in this function, and then paste in the code. Yeah, literally, just take your code, okay? Take your code, all of it, Control A, Control C, okay? Go over to ChatGPT, paste in your code. Then at the end, hit a space and say, give me the function, or add the ability to rotate the image in the event. And then I'm going to grab this before I hit enter though, because we're going to use that. And then hit enter, and it's going to give you various options. It's going to go out and find all those Google sites that you would have normally looked at for examples on how to rotate an image within the environment of Java. And this is the better way, guys. Use it to solve parts of the problem, not the whole problem. Although, once you understand the basics, I'm now at a point where I no longer write code. I write code without writing code. Because what I'm now doing is I embed the AI in my folder, in my project, and I put it up in a terminal, talk to it, and I tell it to write the code for me, and it will literally write the code in the directory, and it will run it and test it and everything. That's why I am trying to get people to understand the importance of working with artificial intelligence as a learning tool as well, but use it responsibly. It can be abused, and you know, when it's being abused, it's very evident. Okay, we're not going to do that one. Okay, let's just go in with the code that I initially grabbed that was pretty simplistic. Let's go up here and let's add the rotate image. Now, the problem it's going to have is it's not going to have access to image view. It's not going to know what it is, because image view is out of scope. It doesn't know. So what is image view? Is that our image? Let's look at the ChatGPT example then. It looks like we're having a problem with hooking up. Let's see how things related here. So it looks like from the example that I got, they are using image view, but look at this. Boom. Look at that. It doesn't instantiate it, guys. It does not instantiate the image view. This is very important for understanding how to make everything work together within scope. All it's doing is defining image view. It's not assigning it equal to new until runtime, right here. And why does it need to define image view at object scope? So that process button knows of it, so that when it's instantiated in this scope, it can use it. And that's why we put it there. So what is our image view? Is that our normal one that we've got here for, or did it add an image view to the code? Yeah, it added an image view. We might have to play around with that. That's going to be a turd. Why is it rotating an image view? That's stupid. All right. Whatever. Let's see if we can just do it with, yeah. So here's our image view. The one that we need to make accessible. It's declared, it's not just defined, but it's also instantiated. We need to define this. We need to decouple this so that it is instantiated in main, but it's defined at a different scope, at the object scope, so that function has access to it. So we're just going to instantiate it here. That's all we're going to do. But we're going to go all the way up here, and we're going to put the definition right there. There we go. Well, yeah, because the image view is what actually draws the image. It's the control. So you got two parts. You got the image and then the image view. And so the image view draws the image, so that's what we're actually going to rotate. It's the control that holds the image. Let's see. I don't know. Let's try. We might have some issues that we got to clean up. Oh, duh. Okay. Let's see if we can actually get comments up. I'm just like, I know you're probably tired. Hopefully you took some breaks. It's like we're an hour and 34 into this. Let's get rid of this. I just want to run it. Let's go. Run, you silly thing. Run. Do what you're supposed to do. All right, it's going. All right, here we go. We got push me. Okay, let's set a breakpoint over here. Let's set a breakpoint. Let's make sure that our event is firing. If you're working with events, you got to make sure it's firing, guys. So I'm going to go ahead and push, and I'm going to make sure that that event happens. Boom. There. It did. It did. It ran. It ran. Step over, step over, step over. Okay, continue, continue. Oh, frick. There. All right, I hit play. All right, done? Yes, done. Woo! We got it. There we go. All right. Okay. Get rid of this stupid thing. All right. So I want to press it. I want to push it. Push, push, push. Oh, it won't let me. Oh, something's going on. Oh, because I got to hit play because I'm still in debug mode. All right. There we go. Got rid of that breakpoint so we can just kind of do whatever. All right, guys. That's event handling. It is everything that I wanted to talk about. We hit the big points. So thank you. Take care. Bye.